Lesson 4. Perform the indicated operation to write each polynomial in standard form. So remember that standard form for polynomials means the exponents are in decreasing order. We start with the highest exponent and keep decreasing until you run out. So to subtract these two polynomials, we can really distribute in a -1 and make it an addition question. So 2x squared minus x cubed minus 9x plus 1 minus x cubed minus 7x plus 3x squared minus 1. I went through and I distributed that -1 in. Now we need to combine like terms. I see the highest power here is an x cubed. I have a negative x cubed and a negative x cubed, which means I have negative 2x cubed. After my x cubes come my x squareds. 2x squared plus 3x squared gives me 5x squared. Negative 9x minus 7x gives me negative 16x. And then 1 minus 1 is 0. You could write the plus 0 or not. So the answer is negative 2x cubed plus 5x squared minus 16x. Key thing with subtraction, you have to remember to distribute that -1. X plus 3 squared minus x plus 4 squared. So following the order of operations, I need to square these first before I subtract them. So how do I square x plus 3? Well, x plus 3 squared is x squared plus 3x plus 3x plus 9. So it's x squared, combine your like terms, plus 6x plus 9. So I have x squared plus 6x plus 9 minus x plus 4 squared. X plus 4 times x plus 4. X squared, 4x, 4x, and 16. Combine your like terms. X squared, 4x plus 4x is 8x plus 16. The key thing is you need to put this in parentheses because you want to subtract it from x squared plus 6x plus 9. So to subtract it, I'm going to distribute the -1. So we have x squared plus 6x plus 9 minus x squared minus 8x minus 16. X squared minus x squared adds to 0, so I don't have an x squared term. 6x minus 8x gives me minus 2x. 9 and minus 16 gives me -7. So minus 2x minus 7 is equivalent to that original expression up there. Number 3, x squared minus 5x plus 6 divided by x minus 3 plus x cubed minus 1 divided by x minus 1. So before I add these two together, first I need to divide. So I'll do the first division by using long division, and then I'll do the second division by using the reverse tabular. You could choose whatever method you're comfortable with. So I'm dividing by x minus 3. What times x gives me x squared? Well, x does. X times x gives me x squared. X times -3, it's minus 3x. To subtract, I change the sign, and I get minus 2x plus 6. What times x gives me -2x? Minus 2. Minus 2 times x is -2x. Minus 2 times -3 is positive 6. This looks good because when I change the signs to subtract, I get 0 as a remainder. So this first expression, x squared minus 5x plus 6 divided by x minus 3, that first expression is equivalent to x minus 2 plus whatever I get from doing this division. So I want to do x cubed minus 1 divided by x minus 1. So I'm dividing by x minus 1. How big is the top of my box? Well, x cubed divided by x is x squared, so I have a quadratic polynomial at the top. So I need a column for the x squared, a column for the x, and a column for a number, so I need 3 columns there. From the diagonal, I need to get out an x cubed from here, but I'm missing terms. Who's missing? I'm missing my 0x squared term, and I'm missing my 0x term. And then we have the -1. Well, x cubed had to be in that box. And we say, what times x is x cubed? X squared. Multiply it through. What plus negative x squared gives me 0x? I want 0x and I have a negative x squared, so that needs to be a positive x squared in that box. X times x gives me x squared, so I get a negative x in that box. I want these two diagonals to add to 0x, so that has to be a positive x. What times x gives me x? 1. 1 times negative 1 is negative 1. It works out. So the second fraction is equivalent to x squared plus x plus 1. So I want to do x minus 2 plus x squared plus x plus 1. So I want this written in standard form, x squared plus 2x minus 1. Number 4, x plus 3 times x minus 3 minus x plus 4 times x minus 4. Multiplication comes before subtraction in the order of operations, so first I need to multiply both of these together. I'll do this using the distributive property one way, and then the reverse tabular for the other way. So I'm picking up an x minus 3 and distributing that into the x, so x times x plus 3. I'm picking up the x plus 3 and distributing that into the negative 3. Negative 3 times x plus 3. Distribute again, I get x squared plus 3x minus 3x minus 9. X squared minus 9 is equivalent to that first product. Minus what? What goes in that parentheses there? I'll make a table for this one. X plus 4, x minus 4. X times x is x squared. 4 times x is 4x. X times negative 4 is negative 4x. 4 times negative 4 is negative 16. When I go through and combine my like terms, I get x squared, 0x, so nothing, minus 16. So x plus 4 times x minus 4 is equivalent to x squared minus 16. To subtract, I need to distribute that negative 1. X squared minus 9 minus x squared plus 16. X squared minus x squared is 0. 16 minus 9 gives me 7. So that expression, that original expression, is equivalent to 7. Determine the first term and last term of this expression when written in standard form without actually computing the product. Explain how you determined your answer. So the first term I'm going to get from multiplying the x's in all of these binomials together. So the first term is going to be 3x times negative x times 4x. We get the highest power by multiplying the most number of x's together. Again, this comes from the distributive property, but we can do this quickly. 3 times negative 1 times 4 is negative 12. X times x times x is x cubed. So the first term of this polynomial is negative 12x cubed, which makes sense because I'm multiplying 3 linear factors together. The product of 3 linear factors should be something cubic. The last term I'm going to get by multiplying all the numbers together. Negative 1 times 2 times 3. The last term is negative 1 times 2 times 3. I don't want any x's in that last term because the last term should be a number when written in standard form. So the last term is negative 6. So that product, without computing it, is negative 12x cubed plus some other stuff minus 6. We know the first term and we know the last term. How did we determine our answer? Whenever you see explain how you determine your answer, you need to write a sentence of, I looked at the product of each of the highest power of x in the binomials and multiplied them together. How did I get the last term? I multiplied all the constants together in all of the binomials. Number 6, what are the area and perimeter of the figure below? Assume there's a right angle at each vertex. So let's tackle the perimeter first. The perimeter is the total distance around the figure. Hopefully you remember that from geometry. But the perimeter is the total distance around this figure. So I know the perimeter is 2x plus 15 from this piece up here, plus 15x plus 10, plus 10x plus 30, plus 6x plus 8. And then I'm missing this purple side here. I'm missing that purple side there. Well, this whole side is 10x plus 30. This little piece is 2x plus 15, so what's missing? What's missing there, this side has to be 8x plus 15, because those two purple sides on the top have to add to that bottom side. So we get plus 8x plus 15, and then I also need to find how long that missing vertical side is. Well, the whole vertical length is 15x plus 10. The whole vertical length is 15x plus 10. I know this part is 6x plus 8, so I'm going to need a 9x plus 2. 9x plus 2 plus 6x plus 8 gives me that whole vertical length. So plus 9x plus 2. And now we get to combine our like terms together here. We get to go through and combine our like terms. Hopefully you have a calculator. 2 plus 15 is 17, plus 10 is 27, plus 6 is 33, plus 8 is 41, plus 9 is 50. So I'm adding 50 x's together. And now we need to figure out what's the sum of those constants. Well, I have 15 plus 10 plus 30 plus 8 plus 15 plus 2. So 15 plus 15 is 30, plus another 30 is 60, plus another 10 is 70. 8 and 2 gives me another 10, so 70 plus 10 is 80. So the perimeter is 50x plus 80. Perimeter is the total distance around the figure. What's the area? Area is the total space on the inside. And we don't have an area formula for this bizarre shape. But what we can do is we can make it two rectangles. I can find the area of this first region and add it to the area of that second region. Area is length times width. So the length, it's 2x plus 15 of this first region times 9x plus 2. So I need to do 2x plus 15 times 9x plus 2. And you get 18x squared plus 135x plus 4x plus 30. So the area of that first region, A1, is 18x squared plus 139x plus 30. Now we need to find the area of A2. We need to find the area of A2. And again, area is length times width. The length times the width. So we need to find what's 6x plus 8 times 10x plus 30. 6x times 10x is 60x squared. 8 times 10x is 80x. 6x times 30 is 180x. 8 times 30 is 240. Add those together now, and we get the area of the second region is 60x squared plus 80 plus 180 is 260. 260x plus 240. So those are the areas of the two regions, and if I want the area of the total figure, I'm going to add those terms together. So the total area is that term, that polynomial, times that plus that polynomial, because I'm adding the regions together. So we get 78x squared, 139 plus 260 is 399 plus 399x. 30 plus 240 gives me 270. So that's the area of the figure, that's the perimeter of the figure. 7. Compute this quotient using long division or the reverse tabular method. You get to choose. I'm going to do the reverse tabular method. I'm dividing by x minus 3. I need to end up with an x to the fourth polynomial. I have an x times what gives me x to the fourth? That's x cubed. So I know this polynomial up here I know the polynomial that's my answer is an x cubed polynomial. It's cubic. Or you could say x to the fourth divided by x. X to the fourth divided by x is x cubed. So I know I get a cubic polynomial. Cubic polynomials have a cubic term, a quadratic term, a plain old x, and a number. So I need 4 columns. From the diagonals, I get out x to the fourth. I get out minus x cubed. I get out minus 6x squared. I get out negative 9x. And I get out positive 27. Well, I know an x to the fourth had to come from there. What times x gives me x to the fourth? X cubed. Multiply through. I want negative x cubed, and I have minus 3x cubed. So I'm going to need to add 2x cubed to that. 2x cubed plus negative 3x cubed gives me negative 1x cubed. 2x squared times x gives me 2x cubed. So now I can fill in this bottom box and get negative 6x squared. I want negative 6x squared, and I have it, so I'm going to put a 0 there. What times x gives me 0? 0. You can put a 0x because it really should be the x term, or you can just put 0. Doesn't matter because I'm going to get a 0 there as well. So from this diagonal, I need negative 9x. I currently have 0, so in this box here, I need a minus 9x. Negative 9 times x gives me negative 9x. Negative 9 times 3. Negative 9 times negative 3 is positive 27 as we want. So the quotient is x cubed plus 2x squared minus 9. Okay, the tricky part came in with that 0 there. That 0, the coefficient of x is 0. Number 8, Amy solved the equation. She stated that the solutions to the equation were 7 halves and negative 6. Do we agree with Amy? Explain why or why not. Well, Amy did the work already, and she found 2 answers. Things are solutions to the equation if I can plug them in and I get a true statement out. So if I substitute in x equals 7 halves and negative 6 into that expression there, I hope it equals 0. So 2 times 7 halves squared plus 5 times 7 halves minus 42. What do I get? Well, hopefully you have a calculator and you can just plug it in, but I get 2 times 49 over 2 plus 35 over 2 minus 42. Not 49 over 2, 49 over 4. Because when I square 7 over 2, 7 halves times 7 halves is 49 over 4. 2 divided by 4 is 2. So I get 49 over 2 plus 35 over 2 minus 42. I'm going to add the fractions together and I get 84 over 2 minus 42. 84 over 2 is 42. 42 minus 42 is 0. So is 7 halves a solution? Yes, because when I plug in 7 halves, I get 0. Now let's see, is negative 6 a solution? And substitute in a negative 6 for x. Well, I get 2 times 36. 2 times 36 is 72. Minus 30 minus 42. That's 72 minus 72, which is 0. So yes, negative 6 is a solution. Explain why or why not. You need to have a sentence. I plugged in Amy's solutions and got true equations. Therefore, they are solutions to the equation. Okay? You could also do this by factoring it. Why factor it when Amy already did the work for us? Number 9, compute this product. So you could do this using the distributive property, or you can use a nice table to keep it nice and organized for you. X squared minus 5x plus 2, x squared plus x minus 3. Find this product. It's a 3 by 3 table. We're going to go through and just multiply. X squared times x squared is x to the fourth. X squared times negative 5x is negative 5x cubed, 2x squared. X cubed times x is x cubed. X squared times x is x cubed. Negative 5x times x is negative 5x squared. 2 times x is 2x. And finally, x squared times negative 3, negative 3x squared. Negative 5x times negative 3 is 15x. 2 times negative 3 is negative 6. We know from our reverse tabular method that our like terms are on the diagonals. So I get out an x to the fourth from that diagonal. Minus 5x cubed plus x cubed gives me negative 4x cubed. Minus 3x squared minus 5x squared is negative 8x squared. Plus 2x squared gives me minus 6x squared. And you combine your like terms there. Plus from this diagonal, I'm going to get 17x. From that diagonal, I get 17x minus 6. So the answer is x to the fourth minus 4x cubed minus 6x squared plus 17x minus 6. And finally, number 10, on a set of axes, graph the function f of x equals x squared plus 5x minus 6 and state the roots of f. So whenever I ask you to graph a function, the first thing you want to do is go to your calculator. Go to your calculator and look at the table. Go to y equals, type in x squared plus 5x minus 6, graph it. Hopefully you recognize that an x squared function, a quadratic function's graph should be a parabola. So I go to my table and I see negative 7 has a y value of 8, negative 6 has a y value of 0, negative 5 has a y value of negative 6, negative 4 has a y value of negative 10, negative 3 has a y value of negative 12, that's off the graph, negative 2 is negative 12, negative 1 is negative 10, 0 is negative 6, 1 is 0, and then 2 is 8. So, do we get that nice parabolic shape that we were expecting? Yes. It's a parabola because it's a graph of a quadratic function. Your graph should look much nicer than mine. State the roots of f of x. This is the key thing here, the roots of f. The roots of f are where it crosses the x-axis, the zeros. So roots are the same thing as zeros, which are the same thing as x-intercepts. All of those phrases represent the same thing. So the roots are when I get a 0. So from my table, I get a 0 when x equals negative 6 and when x equals 1. We see that from the graph, that's where they cross the x-axis.